Hello and welcome back to 3S Game Studio. In this video, we'll be looking over the locomotion module of the new AGR V plugin. This locomotion system allows you to aim and move using a wide variety of methods and provides a ton of variables to make your animation blueprint work a whole lot easier. In this video, we'll be looking over the main functions and we will showcase on how to use them. The AGR locomotion consists of two parts, the Anim instance and the component of your character. The AGR Anim instance is basically going to be a base animation instance that will exist on your skeletal mesh inside your character, and the AGR Locomotion component will be a direct component inside your character. We'll first look over the Locomotion component, its function, and how you can use them. The Locomotion components allows you to manage how your character rotates and its aim offsets and set its animation states and animation pose. We have a couple of different aim methods suitable for different type of games, first person, third person, top down, and then we have rotation methods that are also suitable for different type of games. Now, to explain these rotation and aiming methods properly, I have prepared a quick demo to showcase all of them. For better understanding, I made these arrows to show us our rotations. Here, the orange arrow is the actual character rotation, which is the rotation of the capsule of your character basically. And the orange is the root bone rotation. In our current state, they are always facing the same direction because our root bone is following our character. We are doing it this way, it makes it a lot easier to work with animation, and it also makes the multiplayer environment a whole lot easier because the character rotation is already being replicated by your character movement component provided by the Unreal Engine. Using that is a whole lot easier. So first of all, let's go over the rotation methods that we have. We have absolute rotation, which means your root bone, basically your character mesh, will always be in the same rotation as your character itself. Then we have rotate to movement, which basically means that your character can be looking in any direction, but your root bone will only face the direction in which you move. It's currently following it slowly, but it can all be managed through different variables that are available in the animation instance that we will go over later. The next rotation method we have is rotate to aim, which basically means that our character's root will always try to follow the character's rotation. It will slightly follow behind it. We can again manage it in the animation instance how fast it should be. And then we have rotate to aim at angle, which is similar to the last method, but in this case it won't rotate automatically all the time. It will only rotate when you exceed a certain angle, in this case which is around 90 degrees. And it'll also play turn in place animation, which is very easy to do thanks to the AGR Anim instance. And then we have no rotation, which is basically no matter what you do, what way you move, your character will always be looking in a certain rotation that you set. And now let's get over to the aiming methods. We have free look, which is most suitable for first-person games because it will always try to look at whatever your controller is looking at. And to show it to you in first person, it works pretty well. I'll actually set it to absolute rotation so you can see actual proper implication in the first person games. We can also change it to rotate to aim, and it still works very well. And we can also change it to rotate to aim at angle to see the turn in place in first person and third person. Next we have is free look clamped, which basically means we will look, but the amount will be clamped to a certain amount. So in this case, it's about 90 degrees, and if you go over that, it will just stop rotating and it'll flip to the other side once it reaches a certain degrees. And then we have clamped and locked, which basically means that the switchy thingy that was happening before won't happen now until you go back in the range of where you can look at. And then we have forward facing, which basically means it will always be looking in the direction, or always try to look in the same direction of your root pawn. So if I'm looking back, it won't try to go to the back, it will just come back in the direction of the root. It is very, very useful for the third-person games where you want to create a very realistic sort of character. And then we have look at movement direction, which is, as the name says, it'll look in the direction you're moving at, no matter what direction that is. And then we have no aim offset, which is basically no aim offset whatsoever. And that explains all of our rotation and aiming methods. Okay, now let's have a look at the variables of the locomotion component. First of all, we have the rotation, which, as I showed you, are the different type of rotation, the different type of aiming. The pose it's basically a gameplay tag that you can set. It's only a gameplay tag, it's not a container. You can only have one pose at a time. So let's say you want your animation instance to be in a gun pose, and you can set it to gun pose here, and then you can access it in your animation instance. And you can set it to sword, and you can access the same in your animation instance. Then we have animation states. Now this is a container. You can have more than one gameplay tag in it. You can have both the gun and the sword. You can have, let's say, I want to be able to aim, and I'll add that. I'll add another one that is sprint. And basically, unlike pose, in animation states, you can define that you're aiming and you're also sprinting. So your animation can show both those animation, both the additives, or however you're working with both the IKs, and that basically explains all the main variables of this component. All of these variables are replicated as long as you have this to true. If you set it to false, then if you set it to false, basically whenever you make changes to this, they won't be replicated to the server from client side. Then we have the dispatchers, which are very helpful so that you don't have to do checks on tick to see if it's a sword or a gun, or if it's aiming or sprinting, or if the aiming method updated or rotation method updated. You can just use the dispatchers. You can bind them in your animation graph to the dispatchers. We have dispatchers for rotation movement method update, which provides you the new method of rotation and the old method of rotation. You can use them to process however you like. We have same goes for the aiming, the poses, and the animation states. Animation states is a slightly different because when you remove animation states, it'll only provide the states that have been removed. So let's say if I removed just the aiming, this will only give me just the aiming, so I can just process just that. I don't have to do a lot of loops to see which one were removed from the last time. Now let's have a look at the functions of this component. These are the functions of this component, and we have functions to set animation states, we have functions to set pose, we have functions to set aiming and rotation method. For the animation states, we have set animation state. This will override your animation states. Like this will overwrite all your animation states. It will remove all the current ones and add a whole new container. Add animation state, on the other hand, it will only add to the existing states. It won't remove all the states and then add the new states. And then remove animation state will remove only the specified states. We have set and we have functions to set animation states, we have function to set pose, we have function for aiming and rotation method, and then we have functions to get these variables. So let's have a look at the animation states. So set animation state will basically rewrite all your animation states. Any old state that you had that was not mentioned in the set animation state will be gone. It will be a new gameplay tag that will just gameplay tag container that will just replace the old one. Add animation state, on the other hand, will only add the new animation state. It won't override the old one, it won't delete the old one, it won't remove the old ones. The remove animation state will only remove the animation states mentioned in your gameplay tag container. It won't change anything else. Now you might be noticing that these functions have little arrows on top of them, little lightning bolts. These functions can only be called on the server. These are authority only, so you have to keep that in mind when you're developing your game. You have to manage the RPC calls yourself for these functions. Set animation pose and set aim method and set rotation method, you can call them from client as long as you have update allowed by client checked to true. Set pose will set the gameplay tag, pretty self-explanatory. Same goes for aiming method and the rotation method. And the get function will provide you the required variables that you need, as they are not exposed to the blueprints. They are private variables. You cannot access them from here directly. You can only use these functions to get them. And since I mentioned that it is all multiplayer replicated and very much capable, I should probably also show it to you guys. So I'm gonna run it on a listen server. It will also work very fine on a client too, so I just use that. And here we go. Basically, as you can see, the character is here. It's rotating just on the absolute rotation. The client is on absolute rotation, that's why. If I set it to rotate to movement, it will only rotate to the movement, even on the replicated other client. And setting it to rotate to aim is going to, as expected. And then we have it with a turn in place, and it's also playing on turn in place on the other clients. Same goes for looking at the aim offsets, clamped, locked, and we got forward facing, means it'll always try to look forward, and we got the look at direction, which is going to look in the direction of the movement. So yeah, works on multiplayer very well. Now let's have a look at the animation instance. Basically, to create this animation instance, go to your character skeletal mesh, create animation blueprint, and once you made it, you can go in there and you can just set the anim instance to AGR anim instance. And that is it. That is what you need to do to create an animation AGR animation instance. You can also do it in another way, which will create AGR anim instance by default by going to animation, animation blueprint, select your skeleton, and in the parent class, select AGR anim instance. And that too creates a AGR anim instance. You can use both these methods, they will work very fine. But if you do reparent it, your engine might crash if you already have a lot of stuff going on in your animation instance. Now, what I like to do when I'm making my animation instances is I like to set the warn about blueprint usage. It helps during the further optimization, so we can make sure that our animation instance is very multi-thread friendly. And yes, AGR anim instance is very much supported with multi-threading animation updates. It uses that, and even in this example, we are using the multi-threading animation instances. So in the animation instance itself, there is a very, very important thing that you need to have in it for your locomotion component to be of any use. That is the AGR rotation. This is the node that will rotate your character when you change your rotation methods or whenever your rotation updates, basically. In the class defaults, if we go to configs, we have a few options. We have idle threshold, which is basically how the animation instance is going to decide if your character is in idle. This is basically the velocity for that. The root bone default is going to be the default rotation of your root bone. This is going to be 0, 0, 0 in most cases, but in some cases your skeleton might not have the 0, 0, 0 default rotation for your root bone, so you can add whatever the rotation of your root bone is in your skeleton here. This is necessary for the AGR rotation so that it can keep making sure that your character is oriented in the right direction. And then you have your root bone name. If your skeleton somehow doesn't have a root bone with the name root, which it absolutely should if you are going to use any root motion animations. But we are providing you the option to have different root names. We have rotation speed. This is basically how much it's going to lag behind when we were using the look at aim rotation. It was lagging behind because of this value. If we set it to 0, it will disable the interpolation and it will be all instant. Same goes for aim speed. This is for your aim offset, how slow, how quick it should be. I set it to 0 because in the example I wanted to show first person use cases, and it is best for them to have it at 0. But if you're making a third person game, you want your aim offset to be smooth, so just set it to some value that you find suitable, like here. Now this is lagging behind, and this is very much nice and suitable for a third person game, but not really for a first person game. Next we have start rotation at an angle. You guys saw the turn in place. This is for that. So the turn in place should only start once we exceed 90 degree. If we set it to 45, the turn in place will happen a lot quicker. Let's have a look. And yep, at 45 degrees, it's triggering the turn in place. Then we have aim clamp. This is basically how much of a limit you have horizontally on this axis. Now let's have a look at the functions and variables provided with the AGR instance. So in the variables we have forward speeds, drop speeds, falling speed, pretty self-explanatory. And then we have some bools to know which state our character is in. Is it idle, is it crouching, swimming, in air, falling, flying, or moving on the ground. Then we have normalized movement direction. This is basically your movement direction, but it is normalized, so the max value will always be 1. It's very good if you want to use it in blend spaces. Then in our rotation we have aim offset pitch, aim offset yaw. These two are related to the aim speed here. Then we have relative root rotation, which is what the AGR rotation is using for the rotating your root bone. And then we have direction angle and lean. There are some more variables available to you in the Anim instance, for which you will need to use the binding node, which is called property access. You just type property access and you get this node. In this you have your get locomotion component, and you can access the same variables that you were able to access from your component here. So you can get like your rotation method, your aiming method, your animation states. You can get your pose, and if it is, you need to make sure that before you get your locomotion component that it is valid, and you can do this by choosing get locomotion component dot is active. It's just as simple as going to locomotion component and is active. This will basically work like a is valid node. It's not the same, but it will do the work because we cannot have isValid nodes in a thread-safe function. Now let's go over some of the functions available in the AGR Anim instance. So we have calculate direction angle, we have calculate mesh velocity, we have get delta aim pitch, get delta aim yaw. These two are going to provide you the same value as your aim offset pitch and aim offset yaw, but your get row aim offset pitch and get row aim offset yaw is going to provide you the values without the interpolation that we mentioned here. So those two functions are going to provide you the value without interpolating the aim speed. And then we have is rotating left. There are two more functions that I am overwriting here, which is calculate aim offset rotator and is rotating. Is rotating is basically for you to know when your character is rotating so you can play turn in place animations. And the calculate aim offset rotator will basically tell you where your character should be looking, because as you know, your spine, your root bone is in a different direction than your character, and you need to offset it. You need your pitch, you need your yaw, and this will basically provide you with that. Let me show you how we're using the calculate aim offset rotator and why I overrode this specific function and how you can do it. So if we go into our aim offset, this is our layer for aim offsets. I have directly binded it to the spine bone and made sure that my alpha together always adds up to 1, so we have a perfect looking at angle. So to override any function, basically what you need to do is go to override and just select the function, and that's all you need to know. All you need to do. Now let's have a look at aim offset rotator and why I overrode it. So in this specific case scenario, the aim offset rotator was flipped for my character. So I added an invert rotator so that I get proper value from this function. This is something you should keep in mind, that not every character's rig is always facing the same direction. Their bones might be in have a different orientation, and that is why some might require invert rotator and some might not. Also, if you guys are wondering if you can see these variables, that's because you need to go to this tiny settings button and select show inherited variables, and it will show you all these variables. Now let's have a look at a temporary locomotion system that I created for this example. If you go into the locomotion, we have 4 states, which is idle, start, motion, stop. We go from idle to start when we are not in idle. And then from start to motion, we just do a automatic rule-based sequence and set it to inertialization. And do remember to put inertialization here. This is not something that you need to do. This is not something part of AGR, but it's just a good practice. It'll give you more blended results, like a lot more perfectly blend results. And in the motion, we have a blend space with 1 and -1 axis. And we're basically going to bind our normalized direction, movement direction to this. Next, how do we go from motion to stop? It's also very simple. Just when we are idle, we go back to stop, and then we blend from stop to idle. Same method, automatic inertialization. In the stop, how do we make sure that it always plays the correct stop animation based on the direction you were walking? So for that, you just need to go to your blend space or your blend by bool if you're using that method, and just use the direction angle. The direction angle remembers the last direction you were moving in. So even if you're idle, it will tell you if it was moving backward like 180 degrees, if it was -90, if it was 90, or if it was 0. And now let's have a look at turn in place animations. For turn in place, what I'm doing is I'm basically making another state inside the idle state, because I only want turn in places to be in idle. And in this, very straightforward, you make an idle, and then you make a turn. The turn is going to have, and to transition between them, I'm going to use what is a can turn. This is again a function I made, and I made this function because some rotation methods do not need turning. But when you do need turning, all you need to do is rotating. You don't have to make a function, you can just bind it to is rotating and you're gonna be good to go. And for the transition back to idle, I'm just setting it to automatic, so it works very fine. Forgot that part. When you set inertialization, it's like a very perfect, I wouldn't say perfect, but it's a very nice blending, and you have to add the inertialization node. Anyways, the turn in place, yeah. So you now know how to go from one state to another, but how do you set the animation for turn in place? How I am doing it is I made a variable for turn animation, binded it to the sequence, and then made a function that will only be called on initialize. Now this is very important. You do not want it on update, you only want it on initializing. Initializing is basically before this animation is even considered to play, this function will be called, and once this is called, it will see which animation should be played based on is turning left. It is turning left, I will play pistol turn left 90. If it is no turning left, I will play pistol turn right 90. You can also make it more complex. You can add 45-degree turns, you can add 180-degree turns, and all you need for that is relative root rotation, and you can get the value of how much you're going to rotate, and then use some less than more than values and figure out your perfect turn in place animation. And that is how you decide the turn anim. Now, some might say that you can just use this on initialize update and create a binding, but in my use case scenario, it was missing sometimes. Sometimes it wouldn't be triggered, and then we would end up playing the wrong animation. And that is the only reason I didn't use this. If it works for you, you can use it. It's very similar to this one, and that explains the animation graph. And as a bonus, let's just add foot placement to this animation graph. I have already added it. You already guys saw it in use. I don't know if you noticed it, but it's very straightforward process. You just need to enable the warping. I think it's the warping plugin, and you get this foot placement node. Use that, define your settings here, define your legs. It's a bit overwhelming, all the options, but it is really worth it. You need all this control. And make sure to set the speed curve name. This is a curve generated on runtime, which you can see here. And yeah, that is it. You do this, and then you add leg IK for your IK foot bones, which is a very basic practice. I'm sure you guys are already aware of it. And that is all. That is all you need to have a foot locking and foot placement system, which also works very well on different height of platforms. Like it's really nice. And let me just show you how it looks with turn in place. That brings us to the end of this video. I hope you enjoyed it. If I missed anything or if you have any questions, feel free to join our Discord. I am WaferX, that is WAFFERX on the Discord. You can tag me, you can ask me any questions, or we have a lot of developers on there, around 2000 developers that you can interact with. You can ask help there, you can post your work, you can show what you did with AGR, or if you get stuck, we are there for you. And thank you for watching this video. I will see you in the next video about AGR inventories.